Alright guys, in this video we're going to put together all of the conversions we've learned so far to do some multi-step conversions. One way that you can look at how to do multi-step conversions is a mole roadmap, and you can search for images of this, but it basically looks at all the relationships that you can use. So mole can be changed into grams, liters, or particles. Now, one thing that you will notice, let me scroll down so you can see liters, is that there are only connections going between moles, liters, particles, and grams. You cannot go directly from particles to grams. There's no line attaching it. So no matter what you're converting to, you always have to go through moles. You can also add the actual conversions you need here. So remember, particles to moles is the 6.02 times 10 to the 23rd. Between moles and grams, you're going to be using molar mass as your conversion. And between moles and liters, you're going to be using 22.4 liters. So you can include this and kind of jot this on the side if it helps. But you can use this to look at what steps you need to use. So say you're given particles and you need grams. Well, you're going to have to go from particles to moles and then moles to grams. So it's always going to be that in-between step, but your first step is always going to be to get to moles if you're not given moles. So let's look at how we're going to do some of these multi-step problems. Here's our example. Wants to know what is the volume in liters of 835 grams of sulfur trioxide at STP. So remember, with these problems, any conversion, you're always going to start with what is given. So we're going to start with the 835 grams of sulfur trioxide. We said that our first step was always to get to moles. So we're going to get rid of grams. So that will go in the bottom of our next step to change into moles. And remember, 1 mole is equal to that molar mass. So we need to find our molar mass. So I'll do work for this up top. So remember, we have sulfur, which is 32.07. Add to that, we have 3 oxygens that are 16 apiece. If we add those in the calculator, we get a molar mass of 80.07 grams per mole. So remember, that goes in as our conversion factor, and that always goes with grams, so that number will be on the bottom. So that will cancel out grams, and right now we have moles, but we're looking for liters. So you can just extend and add another conversion factor on here. Since we're looking for liters and not moles, moles will go in the bottom of our next step for us to change into liters. So remember, our conversion factor here is 1 mole is equal to the 22.4 liters at STP. So that will cancel out our unit of moles, leaving us with liters. And so we simply need to put this in the calculator. Remember, any number above the line gets multiplied. Any number below the line gets divided. So we're going to do 835 divided by 80.07 multiplied by 22.4. So our number of liters that the calculator gives us is 233.596. And then go back and deal with your sig figs. Since our original number of 835 grams has 3 digits, we'll round our answer to 3 digits. So we'll round it to 234 liters of sulfur trioxide. You could have done this in 2 separate steps, but a lot of times it's less work to do it in one long step. Just make sure that you're clearly showing your work and clearly able to mark out all of the unneeded units. Let's look at another problem. What is the mass in grams of a molecule of aspirin, which is C9H8O4? So remember, you're going to start with what's given. It tells us we have a molecule, so one molecule of aspirin. Now remember that molecules are tiny, so our mass should be a relatively small number. And I'm just going to do ASP as aspirin. So if we have molecules, which are particles, and we want grams, remember first we have to get into moles. So we're going to get rid of molecules to change into moles. Remember, the conversion is 1 mole is equal to the 6.02 times 10 to the 23rd particles. That will cancel out our unit of molecules, leaving us with moles. But we're looking for grams, so we need to add an additional step in. So remember, we no longer need moles, so it will go on the bottom of our next step. And since we're changing into grams, we need to find our molar mass. So we can do this down below. We have 9 times the mass of carbon, which is 12.01. Add to that 8 hydrogens, which are 1.008 apiece. Add to that 4 oxygens, which are 16 apiece. So 9 times 12.01 plus 8 times 1.008 plus 4 times 16 is a molar mass of 180.154. So remember that number, it's grams per mole, so that will go with grams always. To make 1 mole. That will cancel out our unit of moles and leave us with grams. Now remember, we're only doing the mass of a single molecule, so this should be a small number, so do not let that worry you. So when we type this in, we have 1 molecule divided by the 6.02 times 10 to the 23rd. Don't forget to either use the parentheses or EE button with the 6.02 times 10 to the 23rd. And we're going to multiply by 180.154. So our calculator answer is 2.99 times 10 to the negative 22nd. Grams of aspirin. Now remember, that is a very small decimal number, so that is a good assumption. Because we were not given an actual number to start with, we do not have to worry about sig figs in a problem like this. Let's look at one more. How many atoms are in 53.2 grams of ammonium nitrate? Same deal. Start with what is given. So we're going to start with the 53.2 grams of ammonium nitrate. We're looking for atoms or particles, so we no longer need grams. It will go in the bottom of our next step to change into moles. So since we need grams, we need molar mass, so we are going to add that together. Um, One thing to note is that there are two nitrogens. They're just in separate locations, but you can count them together if needed whenever you're doing molar mass. So we have two nitrogens total, that's 14.01, plus four hydrogens, that's 1.008, plus three oxygens, that is 16. If you counted the nitrogens separately, that's fine, but don't forget that second nitrogen. That's a common mistake that some people make. So put this in the calculator, and you get that your molar mass, hang on, I typed in something wrong. 2 times 14.01 plus 4 times 1.008 plus 3 times 16 is 80.052. I had typed in 11.01 instead of 1.01. So our molar mass, the 80.052, is going to go on the bottom. So that's going to cancel out grams and leave us with moles. But we're looking for atoms, which remember are particles, so we no longer need moles. So that will go on the bottom of our next step. And we can change into atoms. And remember, 1 mole is equal to 6.02 times 10 to the 23rd atoms. So that cancels out moles, leaving us with atoms. So we need to put this in the calculator. So 53.2 divided by 80.052 multiplied by 6.02 times 10 to the 23rd. Remember, with numbers in scientific notation, use your parentheses or EE button. And we get that to 3 sig figs, which is what is given, it's going to be 4.00 times 10 to the 23rd. And remember, your unit is atoms of ammonium nitrate. So all of these problems, no matter what steps you're going through, it's always the same process. Start with what is given, get to moles first, and then you can convert into whatever unit you need. Make sure that you're practicing these, showing your work, and clearly able to cancel out your units.